All right, class. This is the first video on section 6.4 in your note packet on the fundamental theorem of calculus. It starts on page 84 in your note packet. And so at the top of the page, page 84 in a rectangle, we have the statement of the fundamental theorem of calculus, and it says let f be continuous on the closed interval from a to b, right? That's for x, from x equals a to x equals b. Then the definite integral of little f of x with respect to x from x equals a to x equals b is equal to big F of b minus big F of a, where big F is any antiderivative of little f. And so you remember from section 6.1, if big F is an antiderivative of little f, then the derivative of big F of x is equal to little f of x. So we find the antiderivative of little f of x, big F of x, and we evaluate big F of x at x equals b, and then we subtract and evaluate it at x equals a. Little a is called the lower limit of integration, and b is called the upper limit of integration. So let's demonstrate evaluating a definite integral in the first example. And we're going to find the definite integral of x squared plus 1 from x equals 1 to x equals 10. But the antiderivative of x squared is 1/3 x cubed. The antiderivative plus 1 is x. And then, you know, when we find the antiderivative, right, we typically have to add plus c. So the antiderivative of x squared plus 1 is 1/3 x cubed plus x plus c. The bar here, the vertical bar here, is just to remind us that the lower limit of integration is 1 and the upper limit of integration is 10. So following the rectangle up here, right, we first plug in the upper limit of integration 10 in for x, and we have 1/3 times 10 cubed plus x plus c, and then we subtract, right, the minus sign up here, and then we plug in the lower limit of integration 1 in for x. Now when you subtract and put in the lower limit of integration in for x, always put what you're subtracting inside the parentheses, or you'll only change the sign of the first term over here and not the second and the third term. So it's minus parentheses 1/3 times 1 cubed plus 1 plus c. And now we got, it's arithmetic, you got to simplify. So 1/3 times 10 cubed is 1,000 thirds plus 10 plus c. And then we distribute the minus sign and simplify what's inside the parentheses. And 1/3 times 1 cubed is 1/3. So we have minus 1/3, and then minus 1, and then minus c. Now you notice right away that the c's cancel, right? We have c minus c. And then 1,000 third minus 1/3 equals 999 thirds, which is 333. We add 10, subtract 1, and we get 342. So the definite integral of x squared plus 1, x equals 1 to x equals 10, is equal to 342. So this has this value of this definite integral, right, has an interesting meaning. If you remember back in section 6.3 on page 83, right, we computed the Riemann sum for this function, f of x equals x squared plus 1. We did a left-handed Riemann sum and we did a right-handed Riemann sum. So here's the graph of the function that we just did the definite integral with, right, f of x equals x squared plus 1, and we estimated the area under the curve and above the x-axis from x equals 1 to x equals 10. And we got the left-handed Riemann sum was 207 square units, and the right-handed Riemann sum was 504 square units. And so I have that written here, right? Here's the graph again from section 6.3, The left-handed Riemann sum was 207 square units. The right-handed Riemann sum was 504 square units. Well, the answer to our definite integral from x equals 1 to 10 gives us the exact area under the curve and above the x-axis from x equals 1 to 10. That's one of the interesting things about the definite integral, is it gives us the exact area under the curve and above the x-axis. And one other thing I want you to note is that the c's canceled up here. So when you're evaluating a definite integral and you find the antiderivative, you can leave out the plus c, because they will always cancel after you substitute in the upper limit of integration and the lower limit of integration.